Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody and welcome to another episode of Lost in Math. I'm Mr. Wheeler. Today we're continuing talking about quadratic functions, and today we're talking about the characteristics of a quadratic function. We're specifically looking at the characteristics of a quadratic function's graph. If we remember, graphs of quadratics are parabolas. And the first characteristic we're going to talk about is the zero of a function. Whenever we graph a quadratic function, it has to be written in standard form of a quadratic function. Yeah, standard form of a quadratic function, y equals ax squared plus bx plus c. When it's written in the standard form, if I want to find the zeros of a quadratic function, that means I'm looking for when y equals 0. On a graph, y equals 0 here along the x-axis. Every point along the x-axis has a y-coordinate of 0. So if I'm looking for the zeros of a function, I want to find my x-intercepts, where my graph crosses the x-axis, because at those points, my value of the function is 0. Quadratic functions can have 2 zeros, 1 zero, or no zeros. If it has 2 zeros, that means the parabola crosses the x-axis twice. So on this one, I'd have 2 zeros, one there and one there. It could also have 1 zero if it just barely touched the x-axis, like on this parabola. Or I could have no zeros if my graph never crossed the x-axis at all, like on this one. So to find the zeros of a function by looking at its graph, we just need to find the x-intercepts of that function. So on our notes, on examples A, B, and C, see if you could find the zeros of all of those functions. On example A, it looks like our zeros are here at -1 and at +2. So this parabola had 2 zeros at -1 and 2. To check, if I plug in a -1 and a 2, I should get out a 0 if they're actually zeros of my function. So I could do that really fast. Just plug in a -1 for x. Math, math, math. We get out a 0. Same thing for a 2. If I plug in a 2, math, I get out a 0. So those are my answers for example A, -1 and 2. On example B, it looks like my 0 is at +1. Looks like that's the only one, so I check it just to be sure. If I plug in a 1 into my function, I should get out a 0. And when I plug in a 1 for x, I get out a 0. So that's correct. I only have 1 0 on example B at 1. On C, it never crosses my x-axis, so I have no zeros on example C. The next characteristic of a quadratic function that we're going to talk about is the axis of symmetry. When things are symmetrical, they're the same on both sides. So the axis of symmetry should cut my parabola in half and divide it into 2 equal pieces, so that if I folded my parabola on top of each other, it would line up on both sides. And it should always pass through the vertex. That's the low or high point on a parabola, if we remember. So my axis symmetry should always cut through my vertex. So if I wanted to find what the axis of symmetry was, if I knew what the vertex was, my axis symmetry would always be equal to the x value of my vertex. So on example A, my vertex was at -1, 1. -1 is the x value of my vertex. So my axis of symmetry would be the vertical line x equals -1. On example B, we can't exactly tell where the axis of symmetry is. It's in between 0 and 1. I'm not too sure. So if we can't directly identify the vertex, we got a second way to find the axis of symmetry. We can do it by finding the zeros of a function. On B, my zeros are at -1 and +2. Since the axisymmetry cuts my parabola directly in half, the axisymmetry should be directly in the middle of -1 and 2. To find a number that's in the middle of two other numbers, we can find the average. To find the average of something, you add up everything and then divide by how many things you added up. So to find the average between -1 and 2, we add -1 plus 2, and then we divide by how many things we added. I added two different numbers, so -1 plus 2 divided by 2. -1 plus 2 is 1, so my answer will be x equals 1/2, or x equals 0.5 if you like decimals. If a function doesn't have any zeros, or if the zeros aren't easy to identify, like if it doesn't cross exactly at -1, it's like at -1.23876, yada yada yada. Then we need another way to identify an axis symmetry, and luckily there's a formula for that. We can use the axis of symmetry formula. When it's written in standard form, y equals ax squared plus bx plus c, to find the axis symmetry of a quadratic equation, we use the formula x equals the opposite of b over 2a. So b is the number multiplying your x term, so it's that, divided by 2 times a, the number multiplying your x squared term. And after we do that, we take the opposite of whatever the answer is. So if we got out a 2, we'd make it a -2. Or if we got out a -3, we'd make it a +3. So if we look on our notes, we got two examples of finding the axis of symmetry. So take a moment, try those. Example A is y equals x squared plus 4x minus 7. First we have to identify a and b, so we can use our formula. A is a 1. There's nothing in front of the x squared, so we can imagine there's an imaginary 1 there. B is 4. B is 4 because 4 is the number multiplying our x term. So a is 1, b is 4. We plug that into our formula. The formula was the opposite of b over 2a. So x equals the opposite of 4 over 2 times 1. 2 times 1 is 2, so we get the opposite of 4 over 2. 4 divided by 2 is 2, so my answer is x equals -2. So my axis symmetry would be at x equals -2. On example B, the equation is y minus 2x squared equals x plus 3. It's not written in standard form. Standard form, we have to have just y equals, so I got to move that minus 2x squared. To get rid of it, I add 2x squared, do it on one side of the equation, have to also do it to the other. Now it's in standard form, y equals 2x squared plus x plus 3. A is 2 and b is positive 1. So I plug those into my formula. So it turns into x equals the opposite of 1 over 2 times 2. So x is the opposite of 1 over 4. So my answer would be x equals -1/4. Last thing to go over, once we found the axis symmetry, we can use that to identify our vertex. If you remember, the axis symmetry is always the x value of my vertex. So if I have a function, first I could find the axis symmetry by using the formula. Next, if I plug that answer, my x value, into my function, I'll get out a y value. That'll be the y value of my vertex. And then I'll have my vertex, because I'll have my x and my y, making my ordered pair of my vertex. So on our notes, examples A and B, it asks us to find the vertex. Example A, y equals -x squared minus 2x. Step 1, we have to find the axis symmetry. So my a is -1 and my b is -2. I plug those into my formula for axis of symmetry. And then math. And I get out my answer of +1. So my axis symmetry is at x equals 1. I'm looking for my vertex, which is an ordered pair, x comma y. I know x is 1 because the axis symmetry has the same x value as my vertex. I need to find my y. I know y equals -x squared minus 2x. It's the function for my quadratic equation I'm looking at. So I know x equals 1, so I plug a 1 in for x, and I do math. And when I plug a 1 in for x, I get out a -3. So my vertex is at the ordered pair 1, -3. On example B, my function is y equals 5x squared minus 10x plus 3. A is 5, B is -10. So step 1, I want to find the axis of symmetry. So I plug a and b into my formula. I get out positive 1. Opposite of negative 1 is positive 1. So I know that's the x-coordinate in my vertex. I need to find the y-coordinate. So I can plug 1 into my function, do math, and I get out my answer of negative 2. So when I plug a 1 in as my x, I get out a negative 2 for my y. So that's the ordered pair of my vertex, 1, negative 2. So that wraps up our notes on characteristics of a quadratic function. I hope you enjoyed the video. Please hit subscribe so you don't miss anything. And I'll be here. Till next time. Bye, guys. So everywhere along the egg. We're specifically looking at the characteristics of quadratic function, and we're going to on a parabola, my vertical symmetry from a formula. So we got two ways to find axis of So to find the zeros of a function, we just need to find the x. Example B is y minus. Example B is y minus 2x. I have no idea. X plus 3. Example B, A, B, and C, and I can. Stop. So if we look on our notes, we got two examples here. If a function doesn't have any zeros, or if the zeros, the 1 into my formula, and I don't like any of that. Y is 5. So step 1, I want to find the function, and I get out my. So that wraps up our notes on characteristics of a quadratic function. So that wraps up our. Yeah.